it has been my experience teaching this class that students lack an understanding of the basics of graphing. So I'm going to assume that you know how to plot points, with x being the horizontal axis and y being the vertical axis that goes up, down. If you have y equals, it doesn't matter what the y equals is. This method is one I will show you that will work for anything which starts with y equals. Now, I'm going to apologize in advance. This is not a professional video. I'm using a laptop with a webcam, and it's balanced on a table with two chairs. Well, on a table and a couple of chairs. I will have to move it at times. There will be there'll be some goofy things going on, and I apologize in advance. But this is something I hope can get you familiar with graphing as we get started in the course this semester, because you will have to graph. So here goes. I got y equals. It doesn't matter what the y equals is, but I'm going to use y equals 2 to the x power minus x squared. If you don't know anything else about how to graph, all you need to do is start with the lowest integer value on the x-axis and do each one until you reach the last integer value on the x-axis. So start with -3, plug it in, get a matching y. Do the same thing for -2. Plug it in, get a matching y. Do it all the way up until you get to the last value on integer value on your x-axis. So here goes. So I'm going to start with x and y. This is the lowest integer x value. It's the one I'll plug in. So x equals -3, y equals 2. I'll replace x with -3 minus -3 squared. Okay? If you have something down here on the regular line other than the number, you're going to need to put the negative in parentheses. Okay, so to the -3rd power. I'm going to use a TI calculator because most of my students are using those. So this is a TI 30 X2. Well, you guys can read it. Okay? I generally use Casio's, but since most of my students have this calculator, I'll show you how to use this calculator. Okay, so I want to do 2 to the -3rd power. So I'm just interested in this part right here. So, okay, I plug into, I hit 2. Now, to do a generic power button on your calculator, it's going to be the upside down V on this calculator. This one right here. Okay? So 2, hit that button, and then you're going to want to enter -3. Now most calculators have a separate negative button from the subtraction key, so make sure you hit it, and then -3. This is what it looks like on this particular calculator. Hit equals. I got 0.125. Okay? So 0.125 minus -3 squared is -3 times itself. -3 times -3 is +9. Because anytime you multiply two negatives or two positives, it's positive. If it's opposite signs, you're going to get a negative. So 0.125 minus 9 is -8.875. So my first point is -3 is the x-coordinate, and then -8.875 will be the y-coordinate. Okay? So -3, next, so I did -3, now I'll do -2. So y will equal 2, I'll replace x with a -2, okay, minus -2 squared. So the same thing I did earlier, 2 to the negative second power. That gave me 0.25 minus negative 2 times negative 2 will be positive 4. You subtract these, you will get negative 3.75. Okay, so my second point is negative 2, negative 3.75. Okay, so I did negative 3, now negative 2, now we'll let x equal negative 1. Y equals 2, x will be replaced with negative 1 minus negative 1 squared. So 2, generic power button, negative 1, I get 0.5 minus negative 1 times itself is going to be positive 1. 0.5 minus 1 is negative 0.5. So negative 1, negative 0.5. All right? So I did negative 3, negative 2, negative 1. Now 0 is up. 0. X equals 0, so y will equal 2 to the 0th power minus 0 squared. 2 to the 0th power is 1. Okay, your calculators could tell you the same thing. Any non-zero value to the 0th power is 1. This is, of course, 0, so 1. So 0, 1. That's another point that we're going to use. Okay, so I did negative 3, negative 2, negative 1, 0. Now I will do 1. Okay, so x will equal 1. Y would equal 2 to the first power minus 1 squared. Okay, 2 to the first power is 2. 1 squared is 1. So 1. So now I have 1, 1. All right? So now I have done negative 3, negative 2, negative 1, 0, 1. Now it's time for me to do 2. So x, y, x is 2, y would equal 2, x will be replaced with 2, minus 2, and x is, and 2 squared. Okay? 4 minus 4 is 0. So my first point will be over here will be 2, 0. Okay? Now, so I did negative 3, negative 2, negative 1, 0, 1, 2. Now we'll do 3. Y will equal 2. X is replaced with 3 minus 3 squared. 2 cubed. 2 to the third power is 2 times 2 times 2. That's 8. 3 squared is 9, so negative 1. Okay? So x coordinate 3, y coordinate negative 1. Okay? All right. Next step. I did negative 3, negative 2, negative 1, 0, 1, 2, and 3. Now 4 is up next. Okay? So 4, y equals 2 to the 4th power minus 4 squared. 2 to the 4th is 16. 4 squared is 16. So I get 0. So the point will be 4, x coordinate 4, y coordinate 0. Okay? Next step. I did negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. Next step, I will do 5. Okay? So y will equal 2 to the 5th power minus 5 squared. Okay, everywhere where I see an x in the original equation, I'll replace with 5. To the 5th power. And my calculator would tell me the same thing. I'll go ahead and do it. 2 to the 5th power. 2 generic power button 5 is 32. 5 squared is 5 times itself, which is 25. That's 7. Okay, so the point now will be x coordinate 5, y coordinate 7. Okay, and so now I've done negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, and 6. So 6 is the last one. Y equals 2. I'll replace x with 6 minus 6 squared. Okay, to the 6th. 2 x generic exponent power 6 gives me 64, and 6 squared is 36. That's going to be 28. So 6, 28. Now, here's the thing. Here's a problem. 28 is way too large to be graphed on the axes that I'm using. Okay, so as a consequence, I'm going to have to leave it off because it's not practical. Okay, as you can see, the grid that I'm using only goes up to 8, so there's no room for the 28. So here goes. I'm just simply going to plot these points and then put a curve through it. So I've got negative 3, negative 8.875. That's almost 9, so that's where I'll go. Negative 3 on the number line, almost down to 9. Remember, folks, this is a sketch. It doesn't have to be perfect. Okay? You want this done perfectly, you're going to need to use a computer or tablet with a graphing program or a graphing calculator. Okay? So here's this one. Now I'm going to do negative 2, 3.75. So negative 2 on the equivalent of the number line, and then 3 3/4, about right here. Okay? Somewhere between a half and a full. Okay? Somewhere between a half and a full. And then negative 1, negative 1/2. Negative 0.5 is negative 1/2. So negative 1, negative 1/2. About right here. Okay? Then 0, 1. Left, right, nothing, straight up 1. And here's 1, 1. Okay? 1, 1. 2, 0. Okay? 2 on the left, right, up, down, nothing. Okay? Then 3, negative 1. 3 on the number line, and then down 1. And then 4, 0. So 4 on the equivalent of the number line, up or down, nothing. Okay? Then 5, 7. 5 on the number line, up 7. And as I said, 628 doesn't fit. So we're just going to have to leave it off. All right, so this is going to be a curve-shaped graph, so that's what we're going to do. We're going to put a curve through it. Try to connect all the points. Make sure you have an arrow on each end if it extends indefinitely each way. And that's it. That's as far as we can. That's the best we can do by hand in a time-efficient manner. I apologize for this. It's attached to something that you can't see. That's it. That's the gist of it. So just to recap, if you've got y equals, it doesn't matter what the y equals. You simply, and you don't know anything else to do to graph the thing. Just start with the lowest integer value for x that you see, plug it in, get the matching y, and you got a point with the -3 and the y you got. Then you do it for the next x integer x value. Plug it in, get a matching y, you got a point. Okay? And do it all the way until you get to the end. If it's not graphable on the axis you got, ignore it. Okay? And then once you're done, put the line, the curve, whatever it is, through everything. That's it. All right? It'll work for everything which starts with y equals. And with that, if you're in my class, I hope you have a good term. Bye-bye.